Okay, ladies and gentlemen, we're going to divide us some decimals here. Again, our reasoning for doing division, long division, is because when we get to algebra, when we have to do polynomial division, where we have x's rather than numbers, you're going to have to know the process to be able to do the long division with polynomials. So it's all a matter of getting to algebra. With this, we first need to deal with division, because remember, like subtraction, 8 minus 4, the 4 stays at the back, but 48.34 divided by 12, we actually have to put the 12 up front, then the divide sign, then 48.34. Just like we did in multiplication, I want to actually do an easier problem. Let's do 312 divided by 11. Now, 312 divided by 11 would be written like this. 11 out front, because we're going to be dividing 312 with it. Now, our question, our process is as follows. Can 11 go into 3? Well, no, because 3 is smaller than 11. Alright, so if it doesn't go into 3, would it go into 31? How many times does 11 go into 31? Well, let's take a look over here. 11 times 1 is 11. 11 times 2 is 22. 11 times 3 is 33. So, too small. 33 is too big to go into 31. So our answer must be, it must be 11 times 2. So I'm going to put the 2 right above the 31. 2 times 11 is 22. So once you multiply, now I need to subtract. So 31 take away 22, well, that's going to be 9. Now does 11 go into 9? If 11 does fit inside 9, then I would need to move this bigger. But in this case, 9 is smaller than 11. I can't fit all of 11 inside 9. So I have to bring something else over here to help. Let's bring down that 2. 92. So we have 11. Well, 11 times 1 is 11. 11 times 2 is 22. 11 times 3, 33. 11 times 4, 11 times 5, 11 times 6. Well, 11 times 6 is 66. That's not big enough yet. 11 times 7, 11 times 8 is 88. Ooh, I'm in the ballpark. 11 times 9 is 99. That's too big. These are too small. So I need 8 of them. 8 times 11 is 88. Then I subtract. 92. Well, that's borrow the 1, so I get 12, I get 8, so I get 4. Well, that's good because 4 is smaller than 11. Now at this point I can go one of a couple places. I could say 28R4 for remainder. I could say 28 and 4 left out of 11. But in this case, I'm going to use a decimal. Since this would be 312, I could put a 0.0 behind it and not change a thing. And just keep on going. 0, well, 11 goes into 40 3 times. 33, then 7, so 6 times. I can keep going and going and going. Now the problem with this method is I can keep going. Where do I put the decimal? It always goes right above where it is. My answer here is 28.36 if I use a decimal. So that's long division using a decimal when there's no decimal in the problem, because 11 doesn't go into 312 evenly. You're going to have a decimal, a fraction, or a remainder. Now, let's go over here and do it again. Automatically, I have a decimal in the problem, so where does the decimal go? Straight up right here. 12. Does 12 go into 4? Nope. 4 is not big enough. Does 12 go into 48? Yep. 12 times 1, 12. 12 times 2, 24. 12 times 3, 36. 12 times 4, 48. So it goes in 4 times. 4 times 12 is 48. Now here's a weirdo, because when I subtract it, 48 take away 48 is nothing. Well, 12 doesn't go into nothing. If I bring down my 3, 12 doesn't go into 3 either. It doesn't go until I get down to 34. 12 goes into 34. Well, 36 is too big, 24 is too small. So we're going to go with 12 times 2, multiply, put your answer here, subtract, you get 10. Bring down a 0. How many times does 12 go in? Oh, let's see here. 12 times 5, 12 times 6, 12 times 7, 12 times 8. I believe 12 times 8 is the best. 12 times 8 would be 96. And again, I could keep going, but I'm going to get to 2 places and stop. Now, the other thing to remember is if I have decimals in both places, it's still not bad. 2.1, and it's dividing 51.62. But I can't divide if I have a decimal out front. I need to move it back 1 spot. But if I move it back 1 spot in the front, I have to keep everything balanced and move it 1 spot here. So instead of the decimal going straight up here, it goes back where I moved it. 21 goes into 51 twice. 2 times 21, 42. Subtract, I'm going to get 9. Bring down the 6. 21 goes into 96 4 times. 4 times 21. So 4 times 1, 4. 4 times 2, 8. That's 84. We're multiplying. See, division includes a lot of multiplication. Do the subtraction, you get 12. Bring down a 2. All right, I think it's going to go in 5 times. 5 times 1 is 5. 5 times 2 is 10. Then I'm going to subtract. Well, that's not big enough, so I have to borrow. And I come up with 7. This is now 11. This is now 1 minus 0 is 1. I come up with 17. Again, I could keep going if I wanted to bring down another 0. 21 would be 5, 6, 7, 8 times. 8 times. And that's going to be my answer. So, that is dividing with decimals. You first have to do long division, and when you run out of room, you may have to put a decimal and keep going, or have a remainder, or have a fraction. If you already have a decimal, just move it straight up. Do the long division like we're used to. If there's a decimal out front, then I need to move the decimal till it's not in the way. Put it right here. But I have to do the same thing and move this decimal 1 place to balance it. So that's division by decimals. We do it because we have to do it with polynomials.